Today we're going to look at section 9.4, geometric sequences and series. After this lesson, you should be able to identify a geometric sequence, write the rules for a geometric sequence, and show how to use a geometric sequence in a real-world application. What is a geometric sequence? A geometric sequence is a sequence of numbers in which the ratio of any term to the previous term is constant. And we're going to use the letter R to denote that common ratio. So when you divide each term by the previous term, all the fractions, all the ratios are the same. Now we're also going to talk about a partial sum. If we're going to add up a sequence, so a series, and then we sum a number of terms, and that's going to be called a partial sum. So here, given the terms of a sequence, you can determine if it is a geometric sequence by comparing the ratios of consecutive terms. So the ratio R will be equal to the second term divided by the first term, the third term divided by the second term, and the fourth term divided by the third term, and so on down the line. So example, 2, 6, 18, 54, 162, there is a common ratio of 3. 6 divided by 2 is 3, 18 divided by 6 is 3, and so on. That's what we have here for this one. So yes, that's geometric, common ratio of 3. Here, let's take a look. 125 divided by, or 635 divided by 125 does not equal 125 divided by 25, even though these have a common ratio. The first two don't. So no, that would not be a common ratio. So it's not geometric. All right, let's take a look at the rules for writing the nth term of a geometric sequence. So if we're given the first term and the ratio, then we can find the nth term using this formula here. A sub n is equal to a sub 1 times r to the n minus first power. Now don't make the mistake of multiplying a1 times r and then to the n minus 1. It's r by itself to the n minus 1 power and then multiply that by a1. So for example, the nth term of a geometric sequence with the first term of 3 and a common ratio of 2 is given by this formula here. And remember that that is not equal to 6 to the n minus 1 power. Don't do that. Don't make that mistake. So let's take a look at an example. So write the geometric sequence with the first term of a. So that's going to say a sub 1 is 5 and a common ratio of 2. So r is equal to 2. Plug this into the formula that we have up there. A sub n is equal to 5 times 2 times n minus 1. So we're going to take that first term and multiply it by the ratio n minus 1 times to get the nth term in the sequence. So the rule, we've got it up there. So write a rule for the nth term of this sequence. Find a sub 7. So well, let's take a look. It looks like our a sub 1 is 3. It looks like our ratio is 4. 12 divided by 3 is 4. 48 divided by 12 is 4. Now let's look at how we can find a sub 7. Well, we're going to write a sub n is equal to my formula up here. And our n, we want to know what a sub 7 is. So we're going to plug in 7 for n. So 3 to the 4 to the 7 minus 1, or 4 to the 6th power. And if I use my calculator, I should come up with 12,288. So make sure you practice that on your calculator and come up with that value there. For number 3, write a rule for the nth term that has one term of the geometric sequence being a sub 4 is 12 and the common ratio is 2. Well, we're going to have to figure out a few things. We don't have a sub 1, but I do have this formula where a sub n is equal to a sub 1 times r to the n minus 1 power, and I know what r is equal to. It's equal to 2. Well, I know that if I plug in 4 for n, then I have a sub 4 is equal to a sub 1 times 2 to the 4 minus 1, or the third power. And I know that a sub 4 is equal to 12, which I was given. So doing a little bit of math here, a sub 1 times 2 to the third is equal to 12. that tells me that a sub 1 is equal to 3 halves. Now I can take that value of 3 halves, plug it back into this formula here to get a general term for a sub n. And that a sub n is going to be a sub 1, which is 3 halves, times my ratio 2 to the n minus 1 power. Give you a second to jot those notes down. All right, we'll continue on. And as always, you can always come back and revisit this and take screenshots if you need to, or whatever you need to do. All right, let's take a look at how to write a rule if we're given just two terms. Now, we're going to write a geometric sequence. Make sure that it says geometric and not arithmetic. Okay? Remember, arithmetic has a common difference. So that would be a different formula. This is a common ratio. So I have a sub 3 and I have a sub 6, and I want to find the nth term. So here's my general formula. A sub n is equal to a sub 1 times r to the n minus 1 power. Now I can plug in a sub 3, which I have, is equal to negative 48. And plugging in 3 for n, I have a sub 1 times r squared is equal to negative 48. Well, that tells me, although we'll get there, but let's also look at a sub 6. A sub 6 is equal to a sub 1 times r to the 6 minus 1, or r to the 5th power, is equal to 3072. So what does that tell me? That tells me that a sub 1 is equal to negative 48 divided by r squared. And then I can use that as a sub 1. I can plug that into the second equation here. A sub 1, which is negative 48 over r squared, times r to the 5th is equal to 3072. And I can reduce that to negative 48 r cubed is equal to 3072, or r cubed, doing a little bit of math, 3072 divided by negative 48 is equal to negative 64. And that tells me that r is equal to negative 4. Now, an alternate way to have figured out r, I could have done it this way. R to the 6 minus 1, which is 5, minus 3 minus 1, which is 2. So r cubed is equal to a6, which is 3072, divided by negative 48. And r cubed is equal to negative 64. R is equal to negative 4. So these two match. They're the same exact value. Now that I have r, the last thing I have to do then is I know what a sub 1 is. It's negative 48 divided by r squared. So negative 48 divided by 16 is negative 3. And now I have all the terms that I need to figure out what a sub n is. A sub n is a sub 1, which is negative 3, times r, which is negative 4, to the n minus 1 power. I'll give you a couple seconds to jot those notes down. So again, there's two different ways that we could find what r is. Either way gives us the correct answer. All right, we'll continue on. So we're going to define what's called the geometric mean. The geometric means are the terms between any two non-consecutive terms of a geometric sequence. So if a and b are positive terms of a geometric sequence with exactly one term between them, the geometric mean is given by the following expression. Okay, so it's square root of a, b. Now let's take a look. What's the geometric mean of 4/9 and 25/36? Well, the geometric mean is going to be 4/9 times 25/36, 5 over 36 square root is equal to square root of 100 over 324. That equals, if I do the math, 5/9. So that's what's called the geometric mean. All right, a finite geometric series. A geometric series is the sum of a geometric sequence. The sum of the first n terms is s sub n. So I'm going to multiply by a constant ratio. And then I am going to, like we did for arithmetic, here what I'm going to do is I'm going to subtract the series multiplied by r. So I'm going to have s sub n minus r times s sub n. So a sub 1. Now here I'm going to scoot everything over just by 1. And I'm going to have minus a1r minus a sub 1r squared. So these are all going to cancel out. So what am I left with? A sub 1 all the way down to minus a sub 1r to the nth. So therefore, s sub n times 1 minus r is equal to a sub 1, 1 minus r to the nth power. So just rearranging things just a little bit, my sum of a geometric series is equal to a sub 1 times r minus 1 minus r to the nth power divided by 1 minus r. So you want to keep this formula handy. It will really help us to solve series without having to use a calculator. But you can always check your work with a calculator because that's always nice to know that you've got the right answer. So let's take a look at this geometric series. Here I've got a sub 1 r to the I minus 1 power. Okay. So for a finite geometric series, we're going to use this formula here. Here my a sub 1 is 6, my r is -2, and my upper bound is 8. So plugging it into this formula, now I realize this is a lot of writing, but I'm fairly confident you could figure this out. So if you don't get all these notes just now, you can come back and get them later, or you could probably figure it out yourself. So s sub 8 is equal to a sub 1, which is 6, 1 minus r squared to the 8th power, all over 1 minus r, which is a minus -2, so it becomes a +2. This becomes 1 minus 256 divided by 3 times 6. And if I do the math, that turns out to be s sub, s sub 8. The sum of the first 8 digits in this geometric series is -510. Give you a second to jot all those down. All right. For number 2, what do I have? A sub 1 is 4. My ratio is 3/2. My upper bound is 6, so my n is 6. Again, I'm going to do the same thing where I'm going to plug it into this formula. The sum of the first 6, so s sub 6 is equal to a sub 1, which is 4, times 1 minus r to the 6th power, which is 3/2 here, divided by 1 minus 3/2. And again, I trust that you could figure this out on your own, but if you don't get all these right here, then don't worry about it too much. You can come back and get them, or you can figure it out. 4, here I'm going to convert 1 into 64ths. So I got 64 over 64 because this term becomes -729 over 64 all over -1/2. So do a little bit of math. This becomes 4 times 665 over 64 divided by +1/2. Because I switched the signs because they were both negative, so I made them both positive. And I do a little bit of math here. 4 times 2 times 665 over 64. S sub 6 is equal to 665 over 8. Again, it's just a lot of tedious math with fractions in there. So make sure that you can figure that out. But the main thing is know how to set it up. And then if you know how to do your math, it should come up to this. So I'll give you a couple seconds to jot this down, but you might have to come back to it. All right, we'll continue on. Finally, a real-life application. An online video game tournament begins with 1,024 players. 4 players play in each game, and in each game only the winner advances to the next round. How many games must be played to determine the winner? Well, let's look at this. I've got players and how many games. If I've got 1,024, and that means I'm going to have 256 games going on if there's 1024 divided by 4. Those 256 winners are going to move to the second round. Those 256 winners are going to play in 64 different games. So 256 divided by 4 is 64. The 64 winners move on, and 64 divided by 4 is going to be 16 games. Those 16 winners are going to move on. There's going to be 4, and 4, one game left over, and we can sum that up. Well, now we could just add those up if we wanted to, or we could use a geometric series with sigma notation here. So S sub 5 is going to be A sub 1 times 1 minus my ratio, which is 1/4. My upper limit is 5 because I got 1, 2, 3, 4, 5 rounds. And if I do the math, 1024 over 1024 minus 1 over 1024 divided by 3/4 all times 256. Do a little bit of math, it turns out to be 341. Now, if you didn't get all that, that's okay. You could have just added these up to this bottom row here, done it that way. But using the formula, well, we could do it that way. All right, I'll give you a couple seconds to jot that down. All right, and if you need to come back, that's fine. All right, so our homework for today is going to be 9.4. There's the problems there, and here's some Alex suggestions. Again, the Alex is a good way to make sure you understand what's presented in the textbook. And if you have trouble with the problems in the textbook, you can always look at the examples, or you can always ask me a question. All right, so that's what we're going to finish with today. So good luck with that.